Hello students, welcome back to CLARIconcepts, Unleashing Conceptual Learning. Today in this video, in this lecture, we are going to talk about the stream function. Again, I am saying you, this is one of the topic where student has most of the doubts and confusion. So stay with me to get more conceptual clarity on CLARIconcepts. Okay. So let us say, for example, I have the fluid flowing in some direction, okay, and the flow is, let's say, incompressible in nature. And if I would like to understand the flow, I define the Cartesian coordinate system x and y, where this is the origin. And if I plot a point A in reference to this coordinate system, and at this point I found a fluid particle which has the velocity, let's say, VA. And this velocity VA has two components, UA and VA, where U is component along x and V in component along y. Yes, so these are the two components of this particular velocity vector. Similarly, if you find another point, but obvious at this point also the velocity may not be same, it may also be different. So I found another point B and velocity is, let's say, VB, whose components are UB and VB. So now here if you see, velocity is changing with respect to space, isn't it? It is different. So U is different at both the points, V is also different at both the points. Now, stream function is one of the, one of the important part that you can see. Stream function is what? Let us first understand the concept. Let me first show it to you that stream function is represented by a symbol called psi, and it basically is a function of x and y coordinate now in this particular case, right? It is such a function that when you differentiate this function with respect to y, you will get the velocity in x. That means when you differentiate this function with respect to y, you will get velocity in x coordinate. That means u. U is the velocity of fluid in x coordinate. Yes. Similarly, when you differentiate